Assalamualaikum and hi everyone. Today we will continue on lecture 4 of 5, 6.3 Poisson distribution. In this lecture, our learning outcomes are: the first one, we need to identify the Poisson distribution. Second, we need to determine the probability of an event. Third, we need to determine the mean and variance for Poisson distribution. And lastly, we need to solve problems in social sciences and management. The Poisson distribution is used to describe random variables that count the number of occurrences in a particular time interval or space interval, which means that the Poisson distribution is the occurrences happen within interval. Here, let's look at the situation need to be fulfilled in the Poisson distribution. The first one is the number of occurrences is a discrete random variable, which means that it should be in whole number, cannot be in decimal places. Secondly, the occurrences are random. Thirdly, the occurrences are independent of each other. And lastly, the mean number of occurrences is the same for each interval. For further explanation about Poisson distribution, let's listen to Madam Aziana.
According to the Poisson distribution, so we write X and then there's a curly dash, Poisson in the bracket, we got lambda. Okay, we call this is lambda. And then the probability of X accuracy in an interval is given by the formula. So this is the formula of Poisson distribution. Okay, where X is the number of occurrence and lambda means the number of occurrence in a given interval, and E is the exponential, is a constant approximately 2.71828. Let's do this example. So if X is a Poisson distribution where the mean or the lambda here is 6, okay, find the probability by using the Poisson formula. So we know that the formula is given Px equals to X equals to E power of negative lambda multiply with lambda power of X over X factorial. Okay, so when we want to find Px equals to 3, so we just substitute 3 into your X, and lambda here is 6. This is lambda. Okay, so Px equals to 3, we got E power of negative 6 multiply with 6 power of 3 over 3 factorial. So when you calculate in your calculator, E power of negative 6 times with 6 power of 3 equals to, and then divide by 3 factorial, so it is equals to 0.0892. 0.0892. Okay, and then B, the question asks you to find X less than 2. So X less than 2, because of we need to use the Poisson formula, so we have to calculate. If you look at the number line where we got 2, and obviously the Poisson or any distribution must be start from 0 for the discrete random. So 0, 1, 1, 2. So because it is less than 2, so 2 is not included, so it is 1 and 0 only. So we put X equals to 0 plus X equals to 1. Okay, and then we substitute x equals to 0 and x equals to 1 into the formula. So we got e power of negative 6 multiplied with 6 power of 0 over 0 factorial plus e power of negative 6 times 6 power of 1 over 1 factorial. So when you calculate in your calculator, so you get 0.0174. Okay. C, we need to find Px greater than and equals to 2. So if we look at the number line where we got 2 and it is greater than and equals to 2, means that we need to find all this probability. But we don't know the last number of x here. So we take all the probability 1, because when we add up from 0 until the last number of x, we got 1. But we have to minus with the things that not include, which is 0 and 1 here. It's 0 and 1 because of 2 is include. So we need to minus with px less than 2. So px less than 2 we already calculate in part B here. So we just take this value and put it here, 0.0174. So after we calculate, so we will get 0.9826. So we don't need any formula because of we already have the answer at part B. And then the last one, D, we need to calculate, we need to find Px from 3 to 5, where 3 is not included and 5 is included. So when we put into number line, so 3 is not included but 5 is included. So because of this is discrete, of Poisson is a discrete, so we just take the number that include only. So it is 4 and 5. So we write x equals to 4 plus px equals to 5, and then substitute into Poisson formula, e power of negative 6 times 6 power of 4 over 4 factorial plus e power of negative 6 times 6 power of 5 over 5 factorial. So when you calculate by using calculator, so you get the answer is 0.2945. Find the probability by using Poisson table. As you know or you have learned before how to use binomial table, so it is same as a binomial table and you can apply for Poisson table. Okay, so for example, if x with Poisson distribution where the lambda is 5.5, so you open the book, the statistical table part Poisson on page, the Poisson table starts from page 10. So for lambda 5.5 is at page 13. So to find x greater than and equals to 5, so we just look at the table. Directly you take from r equals to 5 and lambda 5.5, so the answer is 0.6425. Okay, this is directly from the table. So we read all the x in the table is greater than and equals to. So for x less than and equals to 5 means that 5 is also included. Okay, it's 5. So 5 is also included. So because of in the table we read the greater and equals to, so we cannot take at the less than part. So we have to take all, which is 1, minus with the part that does not include, which is x greater than and equals to 6. So read from the table. So we got 0.4711. So the answer is 0.5289. Okay, and then when we want to use table to calculate px equals to 5, so means that we have to take px greater than equals to 5 minus px greater than equals to 6. So x greater than equals to 5 is at part A. We already read it from the table. Okay, minus with x greater than equals to 6, which is here, 0.4711. So when you minus, you will get 0.1714. And the last one for D, 3 to 8, where 8 is not included. We got 3 and then 8. 3 to 8. So we have to calculate from 3, 4, 5, 6, 7. So to read from the table, so we have to take at x greater than equals to 3 minus with x greater than and equals to 8, because of 8 is not included, so we minus at 8. If you take 7 greater than equals to 7, so you minus 7, so that's why we have to take at 8, because of 8 is not included. If 8 is included, so we have to take the next number, which is 9. So by reading from the table, so you got 0.9116 minus with 0.1905. So calculate by using your calculator. So you got 0.7211. Okay, so next example. So we got an average of 3 cars arrive at highway toll gate every minute. So if this street is approximately Poisson distribution, what is the probability that exactly 5 cars will arrive in 1 minute? Okay, so we know that the average is lambda. So we got 3 cars arrive every minute. Means that for every minute we got 3 cars arrive. So by define, x is the number of car arrive in 1 minute. So our distribution for part A, so because of the question asks you in 1 minute, so we got x distribute with Poisson distribution where the lambda is 3. So we have to find 5 cars. So x equals to 5. Okay, so for all x equal, there's an equal, so we can just directly use the formula e power of negative lambda, where lambda is 3, and then 3 power of 5 over 5 factorial. So when calculate in your calculator, so you got 0.1008. And then B, 7 cars will arrive in 5 minutes. Okay, so we know that in 1 minute your lambda is 3 for 1 minute. But the question here state it in 5 minutes. So we need to find the new lambda in 5 minutes. So you need to multiply 3 with 5. So we got 50. So this is the new lambda. So we got the new distribution of Poisson. So we got new lambda, which is 15. So we need to find 7 cars. So Bx equals to 7 by using formula as well. So e power of negative 15 times 15 power of 7 over 7 factorial. Then you can calculate in your calculator. You will get 0.0104. And next example, in a library, the mean number of students borrowing books between 8 p.m. to 8:40 p.m. is 8. To find the probability that no student borrows books in the first 5 minutes. So we need to calculate, because of from 8 to 8:40 minutes, we got 40 minutes. So the lambda for 40 minutes is 8. But the question for A, the question asks you to find for the first 5 minutes. So we need to find the new lambda. So we know that for 8 to 8:40 p.m. the lambda is 8. We know that it is 40 minutes. But we need to find for the first 5 minutes. So we need to calculate for 1 minute first. So we know that 40 minutes, the lambda is 8. So for 1 minute, we need to divide 8 with 40. So we got 1 over 5 or 0.2. And for 5 minutes, we need to multiply with 5. So if we take 1 over 5 multiply with 5, so we got 1. So 1 over 5 multiply with 5, got 1. So the lambda here is 1. Answer the questions. So we have to write the distribution, which is the Poisson. In the first 5 minutes, we got lambda equals to 1. And then the question asks to find no student, because X is a number of student that borrows books. Okay, so Px equals to 0. So we have to use formula to make it easy. Over 0 factorial. So when you calculate in your calculator, so you got 0.3679. Okay, then B, at least one student borrows book in the first 15 minutes. At least one, which is X greater than n equals to 1 for the first 15 minutes. So we already know for 1 minute the lambda is 1 over 5, so we just multiply for 15 minutes. So the lambda, take 1 over 5 in 1 minute, multiply with 15. So we will get 3. So this is the new lambda for part B. We need to write the new distribution, where X is a Poisson distribution with a new lambda 3. So we need to find at least one student. So Px greater than equals to 1 equals to, by using Poisson table. So you will get 0.9502. Okay, and then C, we need to find the probability that 4 to 6 students borrow books between 8 p.m. and 8:40 p.m. So we know that the lambda from 8 p.m. to 8:40 p.m. is 8. So write a new distribution with a new lambda. So we need to find Px from 4 to 6. There's an equal sign because of the words 2. And then 4 to 6 both included. So we need to take at 4, Px greater than and equals to 4 minus with Px greater than and equals to 7. So when we read from the table, so we got 0.9576 minus 0.6866. So when you minus, you will get 0.271. Now we are going to learn how to find mean and variance for a Poisson distribution. So if x is a Poisson variable with parameter lambda, then mean is equals to lambda, and variance also equals to lambda, and standard deviation is equals to set of lambda. So if x, we are going to do this example. If x is a Poisson distribution where lambda is 1.8, so find the mean, variance and standard deviation. So as we know, the mean is equals to lambda, which is equals to 1.8, and the variance equals to lambda, which is equals to 1.8, and the standard deviation, there is no square, so we just take a square root of 1.8. So by using your calculator, you will get 1.3416. Take until 4 decimal places.